All right, hello, Physics 30. This is question number 14. This is the last question on the worksheet, and this is the most complicated one, but the skills are very similar. And here we have Tiana throwing a waffle iron out her second-story window at a speed of 2 meters per second. So not just dropping it, but throwing it down at 2 meters per second in hopes that Shannon and Carter will catch it. So really putting a lot of faith in these two. Waffle irons are not easy to catch. The iron accelerates at 9.81 meters per second squared. Yep, that's acceleration of gravity. The waffle iron is actually, the acceleration is in the same direction of the speed, so it's going to be a positive acceleration. It's going to get faster and faster until they catch it. How fast is it moving when it hits the sidewalk 2 meters or 5 meters below and breaks the sidewalk concrete slab in two? So it looks like they did not catch it, but can't blame them. Waffle irons are not that fun to catch. So let's take a look at this question, and I'm actually going to start way over here because I know this takes up a lot of room. You have enough room on your sheet of paper there if you write small enough, but my handwriting on this device is ridiculous, so I need lots of room here. So let's take a look at what we have. Well, we know the initial speed at which Tiana throws this, and that is, oh, I want to get a different color pen. I'm going to go blue on this again. Here we go. So VI, the initial speed, is equal to 2 meters per second. That's a point right there. 2.00 meters per second. Okay. And that's pretty fast throw. So in hopes, okay, and then it accelerates. So we know the acceleration. Again, in this case, it's going to be gravity, and it's 9.81 meters per second square. That's a meters right there. So that's just normal acceleration here on Earth. How fast is it moving when it hits the sidewalk? So the distance that it's going to travel, delta D, this is going to equal 5.00 meters. Okay. What else do we know? Or what do we want to know here? The question says, how fast is it moving? So this is VF is equal to question mark. Now, is there anything else hidden in here? No, we got the acceleration, the initial speed. Usually that's something that sometimes is hidden, but it's given. There's nothing else, no indication of how long this is taking or anything else. So we have all the information we have, and all the information we need. So we've listed the known variables and the unknown. Now let's pick a formula that hopefully just does it once and we're done. One and done. Well, the problem is none of these equations are set up to do that. This one here has VF in it, but we need delta V, which we don't have. This one has VF in it, but we need V bar. So it doesn't really matter. Again, my preference is to go with one that looks simpler and then just work through it. And you'll find out that we'll end up using all four of these equations again. And this one's actually quite complicated as far as rearranging equations, so I'll try to go through that with you and explain what I'm doing here. So let's take a look. Let's go. So delta V, that looks okay. Delta V equals VF minus VI. All right. Now we want to rearrange this equation. So first of all, if there's any zeros, we'd cross them out, but there's no zeros. We want to rearrange this equation so VF is on its side. This is minus VI, so how do we get rid of it? We have to add VI to both sides. So this plus VI here. Okay, so we're adding VI to both sides. So it's going to be delta V plus VI is equal to VF. Okay, and I like to write it just like VF is equal to delta V plus VI. I just like to be on the left hand side, and the right hand side will be everything else. And so we know VI, but we don't know delta V, so we actually have to solve for delta V. Now we've used this equation already, so we can't use it again. What other equation is delta V? This one right here. So we're going to use the equation A bar is equal to delta V. Sorry, let's erase that. That should be delta V delta V over delta T. Delta T. I'm trying to write small here and it's making it look like garbage. Actually, I don't accept that. Here, let's try this. Let's try that again. Alright, A bar is equal to delta V over delta T. All of a sudden I can write perfect. Okay. So we need to solve for delta V. Now if we multiply both sides by delta T, then we have delta T A bar is equal to delta V. We can use this value here and substitute it in that delta V. So let's do that. VF is equal to delta T A bar plus VI. Now we have VI, we have A bar, we just don't have delta T, so we just got one more thing to figure out. This has been used, that has been used. We need another equation with delta T in it. That's this one right here. So now we're going to go V bar is equal to delta D over delta T. Isolate for delta T, so we're going to move delta T over on this side for now, just to keep it simple. And then we're going to bring V bar over on the other side. Delta V is equal to delta D over V bar. We're going to bring this and put it in for that one. VF is equal to delta D over V bar times A bar plus VI. And we can just simply put the A bar up there. Well, maybe I'll do that in this step here, just so it looks a little more manageable, let's say. Plus VI. Alright. Okay, not too bad. We have VI, we have A bar, we actually even have delta D, but we don't have V bar. So, use that equation. Now we have one equation left. V bar is equal to VF plus VI divided by 2. If we had anything that was 0 here, we'd cancel it out. We don't. We're going to put that in there. Alright, VF equals delta D A bar over V bar. Nope, not over V bar anymore. That's what it used to be. But now it is VF plus VI divided by 2. And that's a VI there. VI. Plus, oh my goodness. There we go. There we go. Plus VI. So, we know VI, we A bar, delta D, good. We have VF, we have V of F, so this is good. It's all the variables that we want. The problem is that we have VF on this side and a VF there. And when you first look at this, you might be like, okay, I'm done. It's too much work. I don't know how to get that VF on that side and everything else there. Well, just use all the math skills you have and don't give up on this one yet here. Here we are going to multiply everything by VF plus VI. Okay, so I'm actually just going to write this on the side here. I'm going to say multiply by VF plus VI divided by 2. Okay, so if you multiply this side by that and this side by that, that'll help simplify things. So you're going to have VF times VF plus VI divided by 2. So I'll write this one out. VF times VF plus VI divided by 2. Okay. And then you're going to multiply by this. Well, if you multiply VF plus VI divided by this whole side, like this in brackets, then you have to multiply it by each one. So, oh, what's going on here? Not really need an account right now. Not sure how that got up there. Let's see if I can just, oh my goodness. There we go. Being sabotaged here. Okay. Wow. So we're going to put that up right there. Okay, good. All right, so when we multiply that all out, you're going to be left with delta D A bar, and because that's trying to cancel that out, plus, now unfortunately we have VF plus VI divided by 2 times VI. So you might at this point think, okay, we tried, and look at, now I've created more VIs and VFs, and so now I need to just quit. So don't quit just yet, because we're going to actually multiply this out and see how it's all going to work out. So I'll go up here, VF times VF plus VI would be VF squared, and then you go VF times the plus VF VI, and that's all divided by 2. Okay, and this is delta D A bar, which is nice and simple, and then VI multiplies by both terms in there too. So this would be VF VI plus VI squared, all divided by 2. Alright, still quite complicated. Let's multiply everything by 2, and that will help reduce it down, so that would become VF squared plus VF VI is equal to 2 delta dA plus, now that 2 will cancel out, so it'll be VF VI plus VI squared. And now it's actually starting to look a little bit easier. There's nothing dividing, but there's still lots of garbage in here. Now we're going to actually subtract. So I'll put a little arrow here. I'm going to just say subtract VF VI both sides. Okay, and here you're going to notice that now we have just VF squared equals 2 delta D A bar, and that one's gone now, and that one's gone, plus VI squared. So that's quite convenient that it all reduced down to that, and we have VF just on this side, but as a squared term, so we're going to make it equal to the square root of 2 delta D A bar plus VI squared. Alright. Okay, that's our equation. So you can see it's a lot of work. This was not too much work to get the variables, the unknowns. This was quite a lot of work to rearrange the equations, and this is actually quite a bit of work to manipulate the equation to reduce it down to what we need to. So now the easy part is you just throw the numbers in there. So we have the square root, we probably need a lot of room there, 2 times delta D is 5.00 meters, A bar is 9.81 meters per second squared, and VI is, what is VI? Yes, 2.00 meters per second, and all of that is squared. 2 squared is 4. You can do this. 2 times 5 is 10. 10 times 9.81 is 98.1, so it's 98.1 plus 4, and then take the square root of that. So I'm not expecting such a crazy number here. This ends up being the square root of 102.1 meters squared per second squared. I don't think you can read that, but anyway, VF then equals 10.104445, and I think there's a few more digits there, and we're only allowed to have 3 significant digits, so this should be 10.1 meter per second. So the iron that Tiana throws down, the waffle iron, will be traveling at 10.1 meters per second when it smashes the concrete sidewalk. And there you go. If you have any other questions, please email me and let me know, and I can make a video explaining it. See you later.